Welcome back to the CppChat. Very happy to have a first-time guest and a returning guest here. So let me ask them to introduce themselves. First is Odin Holmes. Odin, you want to tell us a little bit about what you do, who you are?
Sure. Hi, everyone. I'm a microcontroller guy, and I do lots of C++ template metaprogramming on them, which is kind of not typical. I do training, consulting work, contract development. Yeah.
Okay. And returning is Matt Bentley. Matt, welcome. Tell us a little bit about who you are and what you do.
I am Paul White Trash, and I live in New Zealand. And I work on custom containers at the moment, mainly for my own, out of my own interests, but also hopefully in the interests of others, I hope.
Okay. Excellent, excellent. All right. Well, I always like to keep a close monitor on the other, or I should say the real podcast out there, the ones that is done professionally and done really nicely, and that is CppCast. And CppCast did a really great job this week with their guest, and such a great job that I decided I had to reach out and have him on our show too. But anyway, Odin was on CppCast. It wasn't your first time, was it, Odin?
No, it was actually my second time. I actually asked them if there was some kind of signal dead time for guests, like how quickly they could come back, and said, not that I know of. So, okay, be back on.
All right, that's great. Well, so tell us about, tell us a little bit about what it's like to be a guest, but also let's talk a little bit after that about the content, what you discussed. So.
Sure, yeah. Being a guest is actually super humbling because those guys are super professional. Like, also, I mean, the first time I was on there, I totally screwed it up. Like, my Skype crashed in the middle of our conversation, and so we had to kind of start again. And yeah, it was like, oh yeah, I'll take it in stride, and we ended up editing it around a little bit, so it didn't sound like we had any issues. Or I guess this last time I just like started talking about our conference before even saying that we did it, and then they like edited a comment of their own into the beginning of it, so it all then made sense again. So yeah, I'm like, wow, these guys are professional. Like, what if they write code this good?
Well, don't get used to it, because you're not going to get that kind of treatment here, I'm afraid. All right. Well, you were talking about microcontrollers, and you were also talking about the conference. What you didn't make it clear, and maybe it's because I'm the one who's wrong here, but I thought this was your conference, that you were running this conference.
Yeah. Well, it was my company running this conference, and I guess I did talk to all the speakers that I wanted there, but actually, Stefan, one of my employees, did almost all of the organization together with the other guys, and a lot of friends who volunteered. And so for me, I was quite busy with other things. Seemed like I was just going to a conference and it was all completely organized. And so yeah, that was cool.
Well, I hope they all get a raise, because I can tell you running a conference is not much. It's not easy to do. So. All right. Well, did it go well? Is there going to be another one next year?
Yes. We were actually joking that we should just call EMBO++ 2018. We should just call it ++ EMBO 2017, and then only the actual hardcore programmers will come.
Yeah, that's right. The others will just show up a year early is all.
Yeah. Yeah. I was actually super happy with it. I'm not sure that video turned out super good. So that was kind of like the one thing that
you mentioned that.
We're definitely going to do more professionally next year. But the rest of it, yeah, we wanted to do kind of a different conference, and it was kind of a different conference. So yeah, I was really happy with it.
Yeah. Paul is in the chat room.
Oh, one of my employees saying I want to raise in the chat. Oh my
God. Uh-oh, I better be careful.
Not the appropriate venue, Paul. Speak to HR.
speaks in HR. Yeah, well, that's great to hear. And we were just talking. I don't want to spill the beans, but the three of us, we don't have an official thing to announce, and it's not my project, but there may be another conference, and this other conference is. The initial idea was that it would also be an embed conference, but I think they're going to make it, or I should say an embedded C++ conference, but I think they're going to make it a larger, they're going to make it a little larger and make it about C++, and maybe embedded C++ will just be a theme of the conference. But anyway, I'm looking forward to when that gets announced. There's a lot of activity in C++. There's a lot of user groups. The user groups that are there are becoming a little bit more active. So it's hard for me to even just keep up with all the things that are going on. That's not complaining. That's great. So we haven't mentioned the biggest news this week, and this the purpose of this show is news and gossip in C++. And of course, the biggest news this week is that the Standards Committee met in Kona, and they voted out the ballot. And I think what this means is, I'll get it all right here. They had a candidate proposal, and the candidate proposal has gone out to all the national bodies, and the national bodies send back comments, and the comments can be anything, but they tend to be things like, we don't like the way this particular feature is described, or whatever. They can be larger comments as well, like where's concepts, but and the committee is required to respond to all these comments. But a response is just that, it's a response. The response can be, yeah, I hear what you're saying, but we're going to ignore you. No, the point is they don't have to implement everything that the national bodies say, but the idea is that every single national body comment is responded to formally. There's a response. And then when all those national body comments are responded to, and very often the response is, oh yeah, we'll fix that. And so there was a lot of work done this week to fix a lot of issues. No major features that I know of were added or removed or anything like that. But then,
and this is all for C++ 17, yeah?
Yes, so everything's responded to now, and now they have formally voted out an actual wording that will now go to all the national bodies and get a up or down vote. And if the vote, of course, is up, then we have a new standard. And I don't think the vote has ever not been up. So, and it would be a surprise if it was, because of course, who's going to vote on these? The very people who themselves are in the committee. So it's not like it's some big surprise about what's coming. So I suspect everything's on course. If the votes are up, then Herb, as the committee convener, has a lot of paperwork to do. And then when he does all his paperwork, then we're going to have an official standard. So I think we're on course for that. And my understanding is that at this meeting, they were not allowed to actually vote anything into the working draft because it's officially frozen until the vote comes in. That doesn't mean no work happened. They can do a lot of processing of papers, respond to proposals, and do all sorts of stuff. So work can happen, and I'm sure a lot of work did happen. You're not going to get that many people together and just waste all their time. So they did a lot of work. But the working draft itself is frozen until it gets accepted. At least that's my understanding. Speaking on work, I know that Matt had a proposal, and it was discussed this week at Kona. You want to tell us the background first, what it is, why you're proposing it, and then talk to us about what they said in the committee.
Yep. I'll start with the explanation of the name, because this is something that I left out of the proposal, and a lot of people weren't very happy with the name, I think, because they didn't really, I thought it was intuitive and self-explanatory, but it's not. Because Patrice, who is actually presenting it, he's been really good. He's gone out of his way for a lot of people, presenting a lot of the different papers for SG14, including Ringspan. But he he mentioned somebody was talking to him and suggested he should make some jokes about ant colonies and this sort of thing. And I suddenly went, oh, right, there's various different ways people can interpret that word. And one of them includes something which is filled with bugs. That's probably not a good thing. But my original kind of concept of colony was basically a human colony. So in a human colony, assuming limited resources, you have a bunch of dwellings. People move into those dwellings, into different rooms. Sometimes people leave or they die, and new people move into those rooms. If there's not enough space, you build a new dwelling, etc., etc. Sometimes people move out of the dwellings and house gets bulldozed and to make way for another house. And that's more or less in a nutshell how colony works. So you have various different memory blocks with a growth factor, which is the one thing that doesn't fit into the visual metaphor, because houses don't tend to get 2 times larger every time you build a new one. But anyway, so you have memory blocks and you have elements in them. And when you erase elements in the colony, instead of getting that whole reallocation thing that you get with a deck or a vector, it just gets marked down in a skip field. So when you iterate over the colony, it just jumps those spaces. And the next time you insert into a colony, it fills up that memory space again. And when a memory block becomes entirely empty, it gets freed to the OS so that new larger memory blocks can be created at a later point, that sort of thing. So that's the general concept of it. What it's actually for, originally the focus was for gaming. Once I got it into SG14, I discovered there was a bit more interest in it in some other high performance fields. So yeah, that's kind of it in a nutshell.
So is this
unfortunate? Yeah.
I was going to say, is this a random access? Is this a vector-like thing, but has a different allocation strategy? Is that what we're seeing?
No, it's not random access. The iterator is bidirectional. One of the main focuses for it was having a skip field and not reallocating means that you can have pointers and iterators to elements that don't get invalidated as you erase from other parts of the colony or insert new things. So that's very useful for a number of scenarios in gaming, for example. In gaming you have a bunch of different data structures. They all interrelate. They're all pointing to elements in each other. And there's various ways that people get around that, usually by just dumping in everything in there at the start of level and then just like not touching it for the rest of the level or whatever. But for example, you'd have a game entity and it'll reference a sprite and a sound effect. And in turn, it'll also be referencing a quad tree for where it's located on level. The quad tree is also referencing it. So you've got all of these different linkages happening. You want them to be occurring fast. You want to be able to reference from one thing to another thing fast. The fastest way to do that is with pointers. Some people would argue indexes, and in some cases that's true. But you can't do that with a deck or a vector if you're erasing in real time, because your indexes get invalidated for everything after the erasure point, that sort of thing. So it has similarities to a deck because of the multiple memory blocks. It has similarities to an unordered multi-set, but it's not really like any of those things. It is kind of a bit different.
So it's not really designed for traversal. It's designed to store something that you're going to know the address of.
Bit of both. I mean, the traversal is reasonably quick. It's not as quick as a vector or a deck, but it's faster than everything else that's in the standard at the moment. So list, map, multi-set, etc. And part of that is because of the numeric pattern that I came up with, the jump counting skip field pattern, which I don't really like the name of, but yeah. And that's the paper for that has actually been picked up by a journal, so hopefully that'll be published sometime over the next year. And that's really been the key thing that made the whole thing possible. and made it possible to include in the standard, because without that, I was using a Boolean skip field. And if you've got a Boolean skip field, you can't just jump from one non-erased element to another. You have to check every node in the skip field. So the time complexity for one iteration is basically O-random, because you don't know how many elements that have been erased between these 2 points.
Mm-hmm.
So yeah, it did pretty well at the conference. Unfortunately, Patrice had to leave before they presented it, so it kind of just, nobody was presenting it per se. It was just fielded to one of the subcommittees or the subgroups. And the main one of the main things that came back was they weren't sure about the name, and hopefully with the explanation that I've given and that I'll put in it, it'll be a bit more clear as to why that is. But I'm interested in your guys' thoughts as to whether it's a crappy name or not, or whether something else would suit better.
I think you should call it condominium.
Condominium. Yep. Utility warehouse. Industrial zone. Something along those lines.
Or house for bugs. I think that's clever too. Yeah, that's likely to be popular. But you got some good feedback. It's they like the idea.
Yeah, mostly what they wanted was essentially stuff that I'd put in the frequently asked questions needed to move into earlier into the document, into the actual body of it itself. That's really the main thing. The comment at the bottom that I got back from Patrice says, the small group thinks the trade-offs here make enough sense to include in the standard, which is, to my mind, quite edifying. So I'm quite happy about that. Kind of makes, the
and
3
you
years
were
that I spent
psychologically
on it
prepared for having to do yet another submission. I mean, you understand that that's the way this game is played, right? They keep telling you that it's not ready, and you keep giving them another version until one of you gets tired and quits. Eventually they get tired and say, fine, vote it in.
So a war of attrition is what you're describing.
Yeah.
I have good staying power. I'm not worried. Unless I die first, but then Patrice will take over.
I don't think there's a container structure called attrition, so you could, that name's open.
Yeah, well, I mean, I have to admit, having used it for about 3 years, I'm reasonably attached to the name now, but if somebody else comes up with a better name that isn't some variation of deck, multi-set, bag, because those things, the way that they're used is different and the way that they're structured is different, then I'm all ears. So people can comment in the chat or on YouTube or whatever. Joke names are also appreciated. I'm going to make a collection of those. Okay, in fact, yes, I'm going to write down condominium now. It's like industrial warehouse, so I'm going to write that down too.
You're in good company. I will say this. I know Alex told me that he thought vector was a terrible name, and he regretted using it. But he said this is just what people at the time said. Oh no, what you're describing is a vector. That's what we call it, and it is used that way in the languages. But he just thought it was not a great name. Unfortunately, we still don't have a better name for it. I think a better name would have been allocated array. I think that explains what it is. The problem is that allocated array is a little long to type.
Yeah, I think what does Java call it, and what does they call it something different? Just dynamic array or something like that. But unfortunately, that's got other connotations in C++.
Yeah, I don't know. It took me a while to figure out that in Python, a list is essentially a vector. They call it a list. But that threw me off because, of course, I assumed that it was a linked list. Yeah. But no, for them, here it is. It's array list, according to Chris in the chat room.
Thank you, Chris.
And C# is list. So
yeah. In fact, in the looking at the documentation for the Doom 3 engine, they use the term list for something which is more or less a vector as well. So
Okay, so we mentioned just briefly another container that Odin talked about in CppCast, which I believe also was addressed at Kona, and that is Ringspan. You want to tell us a little bit about this, Odin, before you start telling us how they've botched it up? Go ahead and tell us what it is,
And what you like about it.
what you like about it, why
what I
you'd
like
like
about
it to
it.
be there, and then tell us how they botched it up.
Well, I mean, what's going for it is, you know, this essential pattern is in 20 billion devices or something. You know, the essential pattern of, you know, a fixed size piece of memory, and then, you know, head and tail pointers that kind of go around in circles, right? It's essentially a circular buffer. So as soon as they fall off the end, they just start at the beginning again, and you know, it's essentially a way of doing a very you know, cheap to implement, cheap to use, lock-free container. You know, only single producer, single consumer. So the producer will, you know, tack things onto the end of it, wrapping around when it gets to the end, and the consumer will you know, consume those in the same order. And you know, as long as on the architecture you have, which is really easy to do on microcontrollers, actually, as long as you make sure that you know, loads and stores don't get reordered, and the pointers actually get moved after all the data is in the buffer is settled, then it's lock-free atomic. And yeah, this is used. I mean, the main advantage is it's completely fixed time, right? So if you're in some hard real-time environment, then you know, there is no allocation step if it gets full or anything. That just, you know, there is no non-deterministic behavior. It takes the exact same time every time, and it's, you know, it's very few instruction cycles to push something on the end of it. So, you know, if you have some kind of interrupt service routine or something that needs to be super lightweight, then yeah, this is the container that you use. And you know, the reason why, you know, one of the reasons why of those, you know, 20 billion instances of this, the vast majority are written in C. Because I mean, this is also a container. It's not really hard to write in C. I mean, you can forget to mark things volatile or make memory fences in other ways, and that'll obviously bite you. But it's not really a complicated container. It's the simplest way to get things atomic. And yeah, I guess there are some use cases where you don't need it to be atomic, but at least in my fields, the vast majority you do. But they took that out of the proposal.
So kind of the whole point of this is that you're gonna have two different threads talking to this.
Yeah,
or a set of producers and a set of consumers.
Yeah, or even interrupt service routines, which are not really quite the same thing because they don't have their own stack. They just use whatever stack they interrupted. And so this is kind of a special case because since it's not a thread, if it ever encounters a lock that's already locked, that's a deadlock, right? Because it can't just you know, switch context back to whoever has the lock because it may be on their stack, right? So you know, having a real lock-free container is quite important.
I guess the advantage is that it's not going to be in C++17, so you've still got probably another 3 years before something actually ends up being in the standard, which is a lot of time to talk to people.
Well, wait a minute. Let's not. Okay, so we didn't. I don't think you actually gave us how they screwed it up yet.
Oh, well, they took the atomic part out, which I guess you could put back in as like an implementation detail, but then it would be, you know, lock into whichever standard library actually makes it atomic.
So why did they take it out? What was the purpose?
Well, as far as
what do they gain by not having to be atomic?
Well, you don't actually gain a lot because the atomic part, I mean, you don't have some, you know, compare and swap thing you have to do or whatever. I mean, the thing that makes it atomic is basically just that there are memory fences there. So you gain sorry, so you lose a little bit of leeway for the optimizer to reorder things. And, you know, this could be underestimated. I mean, it's the same assembler, just in a different order, right? And this can be underestimated. There can be situations where reordering actually does make things faster or even smaller in the case of, you know, fixed address memory. If you reorder things to where you don't have to load a whole address, you can just address something that you've recently addressed with a bit of an offset, then you can actually, you know, save assembler instructions by reordering. But in this case, you know, I look at assembler quite often, and at least on the architectures I'm used to, I don't really see a huge advantage to the, you know, reordering wiggle room that the optimizer has. And I guess there's another concurrent queue that's in the standardization process right now, which I know nothing about, but it's probably based on some, you know, actual atomic things rather than just kind of being intrinsically atomic the way Ringspan is. And so it's probably too heavyweight for us to really use on microcontrollers anyway. So yeah, in my mind, probably just because nobody's clamoring for it. And, you know, why make something atomic if no one's asking it to be that?
Right, right. Well, you know, there's absolutely nothing to stop you from writing a paper that piggybacks on somebody else's paper. As Matt says, you've got a couple of years before we're going to start locking it down for 20. So,
and end up being all my fault.
Yeah, well, make that, you know, start screaming about the mistakes they've made.
Yeah.
Are you on SG14, Odin?
Yeah, yeah. Well, when I have time, which is, you know, so far been half the, or not even half the times that they've talked about, you know, the conference calls and stuff. But yeah, more and more lately, as I guess this year they're concentrating more on embedded.
Yeah, because I mean, my first thought is talking to people like Jackie and other people who are in embedded in the SG14 group and kind of, you know, banding together a little bit on it. And
if you just had a conference and pull them all together in one place, so you could get them to get them all riled up to speak as one voice, so to speak.
Yeah, well, actually, I mean, the interesting thing about that, which was kind of one of the strategies that we had at the conference, was we had an SG14 meeting at the conference with the whole audience. And the idea was kind of, you know, hint, hint, this is fun, this is not hard, you know, please join in, because, you know, we had some people in the audience from sort of traditional embedded companies who are pretty much all of them not really using C++. And it's kind of a chicken and the egg thing. They're not really using C++ because they don't really have libraries there for their domain-specific needs, and they don't really have libraries there for their domain-specific needs because they haven't been asking for them or helping building them. And so, yeah, it's kind of a vicious circle. And yeah, I hope that there is more involvement in SG14 by you know, people, especially on the sort of hard real-time and bare metal kind of end of embedded. Because I mean, video games are also considered embedded by a lot of people, and that's a very, very different system, right? I mean, there are some things that are in common, but
they are embedded. Yeah,
supercomputers are considered by some people embedded. I mean, it doesn't have a screen, right? It doesn't have a keyboard. It's embedded. So yeah, it's you know, it's the CERN supercompiler. It's just a giant embedded system. And I think that's true. I mean, I think that's it's kind of hard because there's not really a good term for everybody's niche in embedded.
Yeah, there's a big talk about that on the forum recently.
But yeah, I mean, there's a lot of you know, hard real-time stuff that's also not microcontrollers. So yeah, but we tried to get more people participating because. Yeah, I mean, I think it would be too bad if another standard shipped without input from this community, because I mean, we're super invisible, but we're not really small, right? I mean, if you look at you know, a company like Siemens or something, I mean, they have a somewhat similar number of software guys as like Microsoft, at least directly employed, which is just enormous if you think about it. Because like besides some SPS stuff designed in the 80s, who can name anything from Siemens, right? Software stuff. So yeah, I mean it's also huge because productivity is super low. I mean, like an IoT light switch is actually not so much harder than a hello world if you think about it, right? Like it's a message that gets passed on some event, and that's all it is. But people sink 10 man years into it and it still doesn't work. So there's obviously some problems with productivity and quality in the way this domain does things.
Quick question, because I know we went into this last time I was on here, but like from your personal perspective, what do you see as the advantages of using C++ in an embedded domain as opposed to C?
Well, with C, you write your code and it arguably takes longer because you have to write more of your code. But you're at a very, very high sort of level of optimization at that point, right? Because for one, because you wrote most of your code, you can write it sort of specifically for your thing, and debug builds are fast because you wrote very close to what needs to turn, the release build needs to turn into. But then if you want to go further, if you want to go, more optimized, code starts looking really ugly really fast and unreadable. And, you get into like macro metaprogramming and just, terrible things to make it even faster. Whereas with C++, you may argue that you start out, especially in, debug mode, slower, but as you start optimizing things, that usually means you start writing your own libraries, which optimize things under the covers, and the public interface stays readable and clear and code reviewable and so on and so forth, and statically checked by the compilers. So if you're making assumptions about things, you can still enforce them. Whereas in C, as soon as you start doing bit tricks and whatever, and stuff doesn't map well to function calls anymore, then it's basically programmer discipline. And programmer discipline sounds all like, oh, that's going to be secure and whatever if you're not from the, but as a programmer, you understand programmer discipline means the very worst situation you could possibly have, where things actually will blow up and go wrong. And so yeah, you can. I mean, one of the things we've developed is a domain-specific language for special function register interaction, because that's something that's super easy to get wrong. You can forget volatile. You can read from it and then not realize that there are bits that are cleared on reading it, or you can corrupt reserved bits because you didn't mask properly, and all sorts of stuff like that. And our domain-specific language essentially looks like C, but then you're feeding this template monster that goes and at compile time reorders things, merges things, does essentially optimizations based on chip-specific knowledge that the optimizer doesn't know. And so you can do things like that in C++, where you can really get more efficiency and security out of it. It's just somebody needs to go and write the library. I mean, that's kind of the problem now. Like, oh yeah, C guys, go switch to C++, it's great. And then, well, oh yeah, write your own libraries because that's easy to do. So yeah, I mean that's the problem in a nutshell. There aren't good libraries.
I think.
Thank you, sir.
I think that kind of touches on to something that Matt had wanted to discuss about kind of the culture of C++. Because when you're talking about write your own libraries, you're not talking about the kind of libraries that people who are used to writing in C are going to be writing. Yeah. You're talking about template metaprogramming that is intimidating to people who may have 10 years of C++ experience. and they're comfortable with C++, and they may be comfortable with operator overloads, and they're comfortable using templates, but now you're telling them, oh, you're not going to really exploit what we're capable of until you start writing, your own template meta programming. You need to know what enable if does, and you need to know how to deal with variadic templates and all those kinds of things.
Yeah.
And that's, to do modern C++, pretty demanding. It's not, what I tell people is it's not a hobbyist language. If this is not your full-time language, then it's probably not the best thing to use. I always mention to people that when I write code for running the conferences, which I do, I have certain things that I rely on to run the conference. And yet I'm usually the only one who's going to run this software, and maybe someone else that I ask them to help me with. So we're going to have 1 or 2 users, and it's never going to have a large amount of data in it because the number of submissions to the conference is in the low hundreds. And it doesn't need to be secure. It doesn't need to be portable. It doesn't need to be fast. It doesn't need to scale. It doesn't need any of the kinds of reasons why you want to use C++. So I write it in Python. And I don't mean that to be derogatory. I happen to love Python. There's nothing wrong with Python if that's the right solution for what you do. And frankly, if someone came to me and said, I'm a dentist, but I've been thinking about maybe doing programming on the side, what should I do? I'm not going to say, well, here's Bjarne's books, and here's a stack of Scott Meyer's
meta
books.
Programming, yeah.
Yeah, if and on the other hand, if somebody told me, well, they want to be C++ as their hobby, that's fine. But then programming is not your hobby. C++ is your hobby.
Yeah.
But anyway,
I think my thing was because I was away from it for about 10 years, and then I came back to it and I did a small 2D game engine, and then saw the need for the starter structure because I hadn't used a vector before when I started using, because that's how far back I went. The standard template library wasn't used heavily when I was using C++. And so I started using vector and use it. Oh, wait a second. Why is my code breaking? Oh, right. All these things get invalidated here, here, and here. And you don't know that until you look up on Stack Overflow, and there's so many people who get caught out by this. And it's, the cultural message that you get from the conference and stuff. Oh, just use vector, without noting, there are these problems. But as I was making Colony, I started off fairly basic and just doing sort of new and delete. And in fact, I'm working on something else at the moment, and I'm starting off that way again, just because it's simpler to prototype stuff that way than getting into all the allocator stuff. And then as I went on, I had to get into operating new. And then as I realized, oh, that's not what people do now, I got into allocator and then got told, oh, you have to use allocator traits, or at least allow for them. And it's like, oh my goodness, this is, and that's just one thing out of the template stuff. There's so many different things that you have to know. And all of those things are, to really understand those things like enable if and work with them, you need to understand these 5 other concepts. And my concern, or what I'm seeing, is that C++ is in a way railroading itself into becoming a language for experts and not elitists, that's the wrong term, but definitely for experts, and making itself less newbie friendly. And I hesitate to say it, but I think there's also a little bit of a culture around that, people who are experts and take pride in that, which is, it's not a bad thing. It's good to be an expert in language, but you also get a little bit of, oh, you don't know that? Why don't this sort of thing. And I think we were talking earlier, and I don't think that's as apparent on some of the local kind of C++ communities and stuff, but certainly you'll see it on places like Stack Overflow, which is kind of geared for that. But yeah, and I remember the lightning talk by, let's try and remember his name, Timur Doomler?
Yes.
How do you pronounce that?
So he runs the the conference for audio developers for Juice.
Yeah. So he did a lightning talk, and he was talking about readable C++, and one of the comments he made was on the removal of, was it random shuffle?
Yes, random shuffle's gone
yeah.
away to be replaced with shuffle.
Yeah, and now shuffle requires you to input a bunch of stuff, which you're much more familiar with than I am, John. But, you know, to really make use of it properly, you kind of have to understand, again, why randomness is a problematic concept. What are the different ways that we go about fixing this? What their advantages and disadvantages are. Newbies don't give a crap about any of that. They want a random number and they want it now. They're probably going to, you know, and they're probably not going to go back to rand, standard lib or whatever. But, you know, we're not making things easier for them. In a lot of ways, we're making things harder, and we're making it harder and harder to get into as we're adding more and more stuff to the language.
Yeah, I mean, I think arguably what we have here is there's a conflict between correct and convenient, and correct is winning out. Which on the one hand, yeah, correct should win out, right? I mean, you, as they say, if you don't have to have the right answer, I can make it as fast as you want it. So yeah, we want it to be correct, but sometimes correctness is really painfully exact, whereas almost correct could be a heck of a lot more convenient. And I think the idea that you can't do a random shuffle, or you can't call a random number without knowing what a twister is, that's yeah. There's a certain I shouldn't have to. I don't know what the metaphor should be. I shouldn't have to walk 1,000 miles in every direction. Whatever little thing I want to do, and so there, it would be nice if sometimes there was a solution that didn't require that I'm dealing with very, very sharp edges all the time. But one of the philosophies about C++ and the standard committee, I think, embraces this, whether it's something every individual member says or not, and that is that there can't be room for a more efficient language than C++. We can't allow that. And it can be one just as efficient. That's what C is, essentially.
Yeah, that's its edge.
But you can't have, you can't say, oh, this is how we're going to implement graphic processors, how you talk about graphic processors, and have some other language come along and say, we've got a way that's more efficient, because you've overgeneralized the problem and you can't take advantage of the hardware the way you need to. That's just not the C++ way. And we also have to be correct, and we didn't always feel that way. I think rand is probably, it was a little bit, for those of you who don't know the story, I know that I was told many times, oh, don't use rand, it's not good. And I was always a little puzzled by that, because I couldn't imagine, I mean, how is rand documented so that it doesn't do the right thing? Because rand is a standard function. So it's not a question of how it's implemented, it's a question of how is it documented? Because if you look in the standard, it's certainly not going to tell you what the algorithm is, because that's not the way standards work. But everybody says, well, don't use rand, it's not good. So I took the time actually to dig up the C standard, which I didn't even have. I mean, I have the C++ standard, and I look into it all the time, but I didn't have the C standard. So I dug up the C standard and said, what is it about rand? And it turns out it just says it's going to give you a random number. So I couldn't figure out, well, why is that wrong? What's wrong with that? It sounds, how else could you document this, right? Well, so I did some digging and I found out, well, see, here's the problem. Early implementations did a very poor implementation of rand. So why don't we fix the implementation?
People expect it.
That's right. Certain people were writing software where they kind of expected the way that it worked. And so the implementers for the popular libraries were hesitant to change it, because even though the documentation, the standard doesn't say exactly what rand does, it was common knowledge how rand was implemented, and people expected that kind of behavior. And so that's why we got stuck with an algorithm that's poor. So that's why we're in this situation. STL.
I actually got
Stefan Lawawade did a talk on random at CppCon, and essentially is, you know, explain why you don't want to use rand and what you do want to use, and that I think is. And last year I was surprised by this, but we had like 4 different submissions at CppCon for random talks, and I think we took 2, maybe even 3 of them, but it was like,
yeah.
You know, we've never had more than 1 before. We had STLs before. And suddenly one year we got 4 different submissions. And part of it, I think, was because people, I mean, one of the names of submissions, I think it was,
I just wanted a random number.
yeah, I just wanted a random number. And it's a, you know, it's a 60-minute talk about what he had to do just to get a random number. Life shouldn't be that hard. You know, if every little thing I want to do.
Ideally you can do something where you have the default, and the default is kind of what you would expect, and then if you want to go into specifics, then you can do this other stuff. You know, I'm not sure if that's the way it's currently implemented, but I would hope that, you know, that seems logical to me, that you would have a default parameter argument or whatever, however you make it work.
You could imagine a function called, you know, rand int, which is templated on whatever size int you want, and the default value is max int. And if you give it a value of 10, then that means you're going to get a number between 0 and 9, and it's in uniform distribution, and that should be, and it should have some high quality, but maybe not infinitely high quality implementation. Right? And if you really care and you say, oh, no, I have to have, okay, fine. And we've got the entire library. You can determine what the distribution is. You can determine what the generator is. And you can give a flag.
Because particularly when you're like, you know, particularly when you're like prototyping or whatever, you don't care about that stuff. You don't care if it's an accurate random number, or if anything is particularly accurate. You want to get stuff done in a hurry because you want to see how the thing that you're actually interested in works out. And then later on, you can go back and fix it. So with the benchmarks that I did for Colony, you know, I started off with rand, and then a lot longer down the track, I realized, the actual rand function itself is actually taking up a significant amount of the CPU time, which is reducing the accuracy of the benchmark. So then I looked up how to do a very, very cheap rand function called XOR rand and put that in there. So yeah. Anyway, so I kind of figured that's probably the direction we need to go in, is nice defaults and then stuff for the experts.
Well, the problem with defaults is that we get them wrong most of the time. I mean, there are very few defaults where the default is actually what you would want the default to be, right? I don't know.
Good example?
Like, final keyword or explicit keyword on const. Yeah, I mean, essentially, you know, pick a keyword, its default is wrong, right?
So I think we notice the ones that are. I mean, if you do a lambda, the function call operator is const by default. I think we got that one.
Yeah.
You don't want it to be const. You have to say, we finally, it's 2017. Well, actually, I guess that came out in 2011. That one came out. But yes, no, that's the joke. We always get the. Speaking of poor jokes, you've probably all seen the joke where someone implements a random number function. It just says return 5, and then next to it there's a comment that says verified by die roll.
Yeah.
It's a random number, right?
Nice.
Well, I think the reason we're getting it right more often these days is I think stuff is tested more now before it goes into the standard, because a lot of the compilers are, you know, very close to the standard itself, you know, usually out ahead of things that have actually been, like, you know, we have concepts in compilers, we have structure bindings in compilers, we have all these stuff that's actually in compilers and people can bang on it before it actually gets set in stone in writing. Which you know, I haven't been around for a whole long time in the C++ community, but you know, it seemed to me back in the day, you know, people would talk about this on sort of a theoretical level, put it in the standard, and then eventually, like 3 years later, people would actually put it in a compiler and allow you know, people to actually play with it.
Well,
So-
it depends. If it's library, that's not a big deal. We almost, well, in the past, almost everything's gone into the standard library after 2011. Well, went through Boost first, or excuse me, not after 1998.
Yeah.
When the first standard came out, it went through Boost first, so people did get a chance to play with it. But I think that that's harder to do for language features. You kind of have to have your own compiler, and that's I think with Clang that is a little easier. I mean, GCC was open source. In theory, you could add features to it, but in practice, that was pretty hard to do.
Yeah.
And I think that Clang is a little bit easier to do, but even then, it's pretty daunting. I mean, I wouldn't do it personally. You'd
But
have to.
At the same time, off the top of my head, I can't think of any core language feature that didn't get tested out in Clang or GCC. Like even stuff that's slated for 2020. I think there's some like primitive operator dot stuff. I mean, there's people hack it into the compiler just to be able to play with it, which doesn't seem to be something that used to be.
I think this is one of the pushbacks on Concepts Lite is that it's implemented for GCC, but and certainly concepts in general. There was a Clang concepts, but it's not the same. It's not the same concepts. And I think one of the questions that people have is that the Concepts Lite proposal was written based on the GCC implementation rather than the other way around. So there isn't a proof of concept saying, here's this description of a feature, and go off and implement this in your language, in your compiler, and see if you get the same answer we did. And that's that's not as big a deal for something like operator dot. I mean, operator dot's got its own issues, but it's a fairly small. Even I, not a guy writing a compiler, would guess that's pretty small. And Concepts Lite, on the other hand, is anything but small. And so the opportunity for implementations to diverge and still be able to point at the standard and say, no, we did what they said, is going to be huge and scary. But that's the problem with that's the problem with the world, right? I mean, that's when you're talking about changes to language as opposed to changes to library. That's the way it is. I had a friend who worked on a language called Dylan many, many years ago. One of the things he told me about it is that even the control structures were essentially library. So if you wanted to make your own version of do, while, or for, if you want to create a different kind of for, that was essentially just a library, and you could write your own control structures, define them in the language itself, and that's not the way we do it.
Actually, if I can kind of
out of interest,
go ahead, Matt.
Oh no, I'll probably branch more than you will. You go ahead.
Oh no. Well, I was going to rant on concepts, which would probably take a while. So go ahead.
Right. I was just going to comment. Like, there's been some talk here and there over the years about STL2. Has anybody heard any sort of rumors as to any more upright, ideas about that actually being a thing? Of actually,
you mean STD2?
Oh yeah.
Standard template library 2. So the idea of having a new version of it rather than the perpetual incrementation.
We've only got about 5 or 6 minutes left, Matt. I think you just
Might be out of time for that one.
That's kind of a requirement of the Concepts Lite proposal. The issue is if you add concepts to the standard algorithms, you're going to essentially make existing code not work anymore. In other words,
right.
In my class, one of the things I do is I take you through and I develop an example algorithm and evolve it from something you might write in C even into a generic algorithm. And one of the things we do is we essentially invent or discover, which is a better term, the input iterator. But the input iterator that we create is not exactly the input iterator that is required by the standard. It's the standard requires things that the input iterator doesn't, that the minimal input iterator doesn't actually have to support. For example, you might not need to do equality comparison or inequality depending on how you write your algorithm. And so if we define, if in the concept, we say the concept of an input iterator is that it can be both inequality and equality testable, and you happen to have in your code, you wrote your own container, and for it you created an iterator, and the iterator doesn't have both of those, but it works because the library that you call only ever does equality and never does inequality except with the not, then you're working and you're golden. And now we slap concepts on there and we say, no, you have to support the concepts of an input iterator, and your code breaks.
And again, we're adding to that complexity.
Right. So we've got 1,000 possibilities for that. And so the only realistic solution to that is to say, oh, we're going to create a new namespace called std2, and in std2, it's essentially the entire library that existed before, but now we've added concepts to it. So we don't break any of your existing code because your existing code doesn't use concepts. But if you want to use the new code and you want to get better error checking, because we can tell you that you passed the wrong kind of iterator, or why it was that this isn't really a type that we support, or blah, blah, blah. All the advantages, right? But the price we pay is that for backward compatibility reasons, we got to have a second attempt. This is, I mean, I think we're all going to rant now. We don't have much time left. My rant is that I want to go back and fix some of the things that are broken in the library that we're never going to fix. And one small, slight example of what I'm trying to talk about is in max, the definition of max is that if the two values are equivalent, we return a reference to the first rather than a reference to the second. And that was what Alex proposed. But Alex is the one who later on came along and said, oh, no, that's the correct decision for min. But for max, you want to return a reference to the last. And why you do is basically because you want to retain sort order. You don't want to swap it if it's blah, blah, blah. The point is, I don't want to see us, which is what I think the concepts light is essentially doing. It's basically, we've taken everything that's in the library as is and added a bunch of concept definitions to it. And I think, no,
but then not taking the opportunity to do other things.
To rethink this.
Because the reason...
do we really want to have a specialization of vector bool? Do we really want to say that the partitions into all the truths before all the falses? I think there's a lot of things in the standard library that are wrong and could be fixed. They're not worth breaking existing code.
The reason I asked is because the new thing that I'm working on is just basically figured out how to make a standard list, but actually make it perform well. But, you know, one of the things I've realized is that certain things would be broken if it's done in this particular way. So anyway, that's my reason. But it's interesting that it ties into the concepts thing. I wasn't aware of that at all.
Yeah, that was I think that's the main pusher, because otherwise, I mean, I'd be one who'd say, wait a minute, I don't want to STD2? Are you crazy? We can't even figure out how to use, you know, most programmers literally don't know half of what's in STD. And let's not compound that by having an STD2. But concepts may in fact be worth it. And so, gosh, we have come to the end of the time. I don't know if our chat room was larger because we're at a different time. I'm glad it made it possible for you to join us, Matt. I hope it wasn't too inconvenient for you, Odin.
Yes, this poor man Odin is up at a very, very early time in the morning.
Well, I've got a teething kid, so I'm up this early a lot of the time.
Oh. Oh, right. Well, I don't feel that sorry for you then. Well, actually, I feel more sorry for you that way.
I neglected my hostly duty. I did not read the disclaimer. So before we go, I'm going to say that the information provided in this show is designed to provide helpful information on the subjects discussed. This show is not meant to be used, nor should it be used, to diagnose or treat any medical condition. For diagnosis or treatment of any medical problem, consult your own physician. Thank you guys very much. And
thank you.
I hope you're join us again. I hope this wasn't too traumatic for you. And to everyone, I want to say safe coding.
Safe coding.
Safe coding.